Raise your hand and give me all 8 answers for the top. Cameron, what do you have?
Alternate interior.
If I use abbreviations, you can use the abbreviations on the quiz or a test. So alt int, I understand. AI, I don't understand. Alt int, I will understand. Corresponding, I will take CORR. That would be fine. Same side interior. What would be another name for that? Consecutive. So you could have consecutive interior for the same problem. For number 4, corresponding. That looks good. For number 5, alt X. Once again, alternate exterior. Alt int. And the last one?
Same side exterior.
So the same side interior again?
I got same side exterior.
Exterior, yes. Have we talked about that? No, it's one that's not used a lot. If we look at 1 and 7, where are they? Interior or exterior?
Exterior.
They're in the exterior. Are they on opposite sides of the transversal or same side? Hence, same side exterior. This one looks obtuse to me. What does this one look like? So what do you think their relationship is? Don't say linear, say supplementary or 180, because they're not next to each other. Linear implies that they're adjacent. In this case, you could also put 9, because it wasn't one of the actual choices. It's one that doesn't come up a lot. We use the other ones quite frequently. For this section, there's room for debate, and if you can justify an answer, it's correct. So just because it says always, sometimes, or never doesn't mean that you can have different or multiple answers to the same question. Number 9 says 2 lines that do not intersect. What do you normally think of when 2 lines don't intersect? Well, what could it also be? Sometimes. And in order to say sometimes, we have to be thinking 3-dimensionally. If you're talking about 2 dimensions in a flat surface, then it would always be parallel. But once we introduce 3-dimensional space, then remember we did this? Yeah. This line and this line are not touching. There's a space in between, but they're not parallel. They're skewed. So we're thinking of 3D skew lines in a 3-dimensional space. 2 lines perpendicular to a 3rd line. I'm going to say sometimes for that, because we're going to think 3-dimensionally again. If we're talking 2-dimensionally, the answer would be always. If you have 2 lines that are perpendicular to a 3rd line, they would always be parallel. They would look something like this. Here's a line. Here is a line perpendicular to it. Here's another line perpendicular to it. Would they be parallel? Yes. That's 2-dimensional. But imagine that I bring in something from 3-dimensional space coming in straight into the board. Is this line that's represented by my pencil perpendicular to the line?
Yes.
Depends on how you define perpendicular. If you define perpendicular as only occurring in a 2-dimensional space, then your answer to number 10 would be always. If you allow for something to be perpendicular in a three-dimensional space, then your answer would be sometimes. So if I'm thinking 3D, I'm thinking sometimes, because I could have something coming into the board that's also perpendicular, but it's not necessarily parallel to the other two lines. Yeah. Can everybody see that or visualize it? Don't worry too much if you can't visualize everything immediately. This type of problem, I'll probably have straightforward questions that aren't open to interpretation on quizzes and tests. Something like number 11. There really is no it's not open to interpretation. Two lines that lie in parallel planes are blank skewed. What would you say? KP? Two lines that lie in parallel planes. I'm going to put sometimes. Well, let's think about some parallel planes. Let's look at the room. Back wall and the front wall, are they parallel? Let's place a line on this one. Let's make this a line. It's at a diagonal. Then look at the lines formed by the cinder block on the other wall. Are those lines parallel to this line? No. So they're not touching, and yet they're not parallel. That would mean that they are skewed. The cinder block lines on the back wall and the cinder block lines on this wall, are they parallel? Yes. Hence, sometimes. Yes.
I'm so confused on this. It's like
Skew? Skew, we've got to be in three-dimensional space. If things are on a flat surface and they don't touch, then they're going to be parallel, right? But once we get out into 3D land out here, I could pretend my arm is a line. Pretend this arm is a line. Well, they're separated by my torso, which has depth. Is this line running straight up and down ever going to touch this line running this way? But are they parallel? No, they're skewed. They don't touch, but they're not parallel, so they must be skewed. Two parallel planes cut by a third plane, then the lines of intersection are, what do you think for number 12? Always. Look at the room again. We want two parallel planes to start with. So let's go with the back wall and the front wall again. Then they're cut by a third plane. Well, look at the ceiling. The ceiling's a plane. It's cutting through the back wall and the front wall. Where does the ceiling touch the front wall and the back wall? It touches it along that joint of the ceiling. Is that line parallel to that intersection line back there? Yes, it will always be that way. No matter if I cut through at an angle, or if you look at the floor, that's another plane that touches both of those walls. You can see the black strips. Back and forth, front wall, back wall, they're parallel. So that's always. Yep.
Okay, for parallel lines, do they have to make not parallel, perpendicular lines, do they have to make a right angle?
Yes, that's the definition. Two skew lines are blank coplanar. Never. And that's the whole point.
Because they're
when
skewed.
when I'm talking like this, there's space in between. They're not coplanar. If two parallel lines are cut by a transversal, so parallel, cut by a transversal, same side interior angles are always.
I got two right.
And those first two were open to interpretation. If you're talking about two-dimensional worlds or situations, then you could write in always in those spots. But once you start considering three-dimensional space, then you got to start thinking about other options and counterexamples. Visualizing geometry is a learned skill. Some people can immediately do it, some people need some time. Don't worry too much if you don't get it the first time. Measure of the angles named. Notice, we have two parallel lines. I know they're parallel because of the arrows. Then I have a bunch of transversals. I have a transversal here, which creates two systems. Then I have another transversal over here, which creates two systems over here. So I have to decide what systems I'm focused on as I work through the problem. I see that I have 130 degrees there. If I know one angle, I know the rest in those two systems. So I just start filling in. I don't even start the problem by looking at the problem. I just start filling in what I already know based off of one angle. Then I'll look back over here and start filling in. I said that was 50, 2 was 130, 3, another 130, 55 is 50. How about angle 8? What's your justification for saying that that's 90? Corresponds to this one. The only reason we can say this is because we have parallel lines to start with. If we don't have parallel lines, then we can't say any of this. Yes.
So, in order for us to be able to use corresponding angles, it always has to be parallel lines.
In order to say that they're equal, we can call them corresponding angles, but we can't say that 8 is 90 degrees unless we know that things are parallel. The names we can use all the time, the relationships like congruent or supplementary, we have to wait until we have parallel situations like here and here. Parallel, 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 parallel. So all of these are supposed to be parallel. 23, 24, 25 is a little bit different than this one because now our transversals are also parallel, which means that you might have to shift your focus and your orientation or your view based on the systems you're looking at. I could be looking at this system and this system, or I could be looking at this one and this one. Depending on the two systems you're looking at, you might have two different parallel lines and a different transversal that you're focused on. If I'm looking at those two, this would be the transversal. If I'm looking at these two systems, then this is the transversal. I see 110 degrees. Did everybody put 70 there? What would be your justification? Camera?
They are supplementary.
Why? What name? What's their name? If this is the transversal and these two are the parallel lines, what kind? Consecutive interior. So they're supplementary, so that's 70. If you're just giving a variable, you don't have to put a degree symbol over here. It's just a value. If it actually asks for a measure, that's what this is referring to, then you have to put in the degrees. So I'm just going to put 70. If these are parallel and these are parallel, then I can move around all of these numbers. All of the systems are the same. Taylor?
I just have a question. Do consecutive angles always equal 180 degrees?
Yes. Consecutive interior within a parallel line situation, cut by a transversal. Can I say that 2y is also 70? That's my equation for this, which gives me 35. You don't need to put a degree symbol. It's a value. And what should 2z be? 2z is 110, and z 55. Some things didn't come out on this smartboard file. There should be degree measures here, 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 here. If you don't see the degree measure like that on your variables or your variable expression, you're dealing with a distance. So those should all have degree measures on them. And what kind of angle pair do we have for 26 and 27? Another consecutive interior, which means 9x plus 2 plus 6x minus 2 equals 180. If you solve for x, you should have gotten 12. And for 27, we do need a degree symbol because we're asking for a measure. If I extend this and this and this, what kind of angle pair are 110 and 3x minus y? It's just like all of these. They're all consecutive interior. So I can set up this equation. 110 plus 3x minus y equals 180. Correct? Because they're consecutive interior? Well, if I take that away and extend this one as the transversal, and these two are my parallel lines, that means 3x plus y and 130 are the same. They're equal to 180. 130 plus 3x minus y equals 180. Plus y, thank you. So same classification. They are consecutive interior. How do you solve two equations for two unknowns? What did you learn back in algebra? You could substitute. You could make one variable equal to everything else, get the variable alone, substitute. What's an easier way in this case?
Elimination.
How about elimination? Do you remember that? How about if I move 110 to the other side and 130 to the other side? I end up with 3x minus y equals 70, and I end up with 3x plus y equals 50. How do you do elimination with two equations? Can I just do a big addition here? 6x. These go away. Remember that? Eliminating a variable so you can deal with one variable at a time. X equal to 20. That's the answer to 28. How do you get the other variable? Punch it back into your original, one of your original equations. So 3 times 20 minus y equals 70. 60 minus y equals 70. Y ends up being a negative 10. And that's okay. It's a value. It's not the ultimate measure of the angle. It's just the value of the variable. How many people remembered their elimination method? Could you also graph this if you had more time and you wanted to do that? You would end up with a point of intersection that would be the point 20, comma, negative 10. Keep that with all of the rest of your Chapter 3 parallel line materials.